All right, welcome back, everybody. We are looking at hypothesis testing. That is what the rest of the semester is on. That is what 80% of your final is on. Okay? 80% of your final involves you doing the next 5 steps for 8 different problems. 5 steps of hypothesis testing. Step 1 is the only one that ever changes. No matter which test you do. And it doesn't change by a lot. You will have 2 conflicting hypotheses. You will have the null hypothesis, which goes by H naught or H0, and you will have an alternate hypothesis, which goes by, depending on where you're looking, H1 or HA. The homework will reference H1, and then StatCrunch uses HA. This thing is the same for both. The left side and the right side of the inequalities are the same for both. H naught has an equal sign between them. H1 or HA is either non-equals, less than, or greater than. That's the only difference between those. H naught and HA's only difference. On the left side, when we're doing one sample, we'll have our parameter goes on the left. This is P for proportion. We could be looking at the mean. We could be looking at the standard deviation. We could be looking at something like P1 minus P2 when there's more than one group. There's different things that go in over here. This is what changes for all the hypothesis tests. It's the only thing that changes. Everything else stays the same. Step 1, the rest of step 1 is the same. You still need an equal sign for H naught. You need an inequality symbol for HA. And over here, you will have some value, which is problem dependent, based on problem. Your job on the test will be to read the problem and tell me what these are. H naught and HA, what are they? A handy way to do it is identify what type of test it is. We'll be covering that over the next 2 days. Step 2 and step 3 are kind of interchangeable. You need them before step 4. Both before 4. 2 will be identify alpha, the level of significance. If none is given, use alpha equals 0.05. This is very, very, very much related to the confidence intervals. related to confidence intervals. And you're going to see that in the problems we do today. I'm going to use CI for confidence intervals from now on. I get tired of writing it. If HA is the non-equals, then 1 minus alpha times 100% is our CI percent. So like alpha equals 0.05 leads to a 95% confidence interval. If HA is greater than or less than, you kind of want to do 1 minus 2 alpha. They do it a little different in the notes, but this is much more clear. So alpha equals 0.05 would be 90% confidence. Step 3 is StatCrunch work. Find test stat and p-value. Which I'll start calling p-val. I'll pause and give you guys a chance here. Okay, you guys ready for the next? Nope, people are still ready. Patience Jedi. All right. Step 3, I just said step 3 was get the test stat p-value. Step 4 is where like the decision making really, well, step 1 you had to decide what H naught and HA is. Step 4 is where the next part of the decision making process comes. You're going to compare p-value to alpha. You're going to have two outcomes, two possible outcomes. Outcome A, alpha. Oh my God, I wrote that down wrong earlier. Holy shit. If p-value is less than alpha. Oh my God, I told the last class the fucking wrong thing. And I went on to do the correct thing the rest of the fucking class. And no one said, hey, that doesn't match up with the what we did before. I need to fucking clarify this tomorrow. So if p-value is less than alpha, less than means it's lower than. The way I remember this is if p-val is too low, reject the hoe. That's your Hefe approved memory system. It's really H naught or null, but it looks like hoe. So what this means is we will reject H naught, reject the null hypothesis. We will support the alternate hypothesis. And that's going to lead to sufficient evidence for step 5. Now the other one, I think the easiest way to do it is if p-val's not too low. If you've memorized the first one, this is just follows along with it. Not too low. We do not reject H naught. We do not support HA. And there is not sufficient evidence. Not sufficient in step 5. Yeah, the easiest way to remember this last part. Not. All the nots go together. Jesus, I fucking butchered that word. There we go. Step 5, we will state the conclusion. Which is always about HA, not H0. I cover this in lecture every semester, several times. I repeat it in the practice final when I do the practice final. And then I have students that fucking clearly ignored me all goddamn semester. Write their conclusion about the null hypothesis and usually mangle it all up already anyways, because they weren't paying attention. Of course they got it wrong. You can basically follow a little pattern. There is sufficient or not sufficient evidence to support the claim that, and then you will paraphrase HA here. Or just copy, you can almost sometimes just copy it word for word from the question. At the alpha equals blank level of significance. This last part isn't absolutely necessary, the alpha equals part, but it's good practice. It lets whoever reading it know just how serious it is. So you're going to do this and you're going to pick one. You're going to pick one of these and it's based off of 4. You either have, we have sufficient or we do not have sufficient. I need to put this in my notes to point out tomorrow that I did them wrong earlier, like a dirty dog. Now, hypothesis testing, what we're doing is we have an assumption about reality, and we're gathering data to see if it's true. Usually, there's a pre-existing assumption, that's our null hypothesis, and we've decided something's changed. It's either gotten smaller, it's gotten bigger, or it's just different, but we don't know how. You guys ready for more? All right, chapter 10 is on one sample tests. (10.2) is on one proportion test. I call it 1P test, which is one proportion, one sample proportion. H naught and HA are P equals something, and then P doesn't. Some number over here that we don't know. Problem dependent. If you've been doing your homework, the criteria you will have seen. N times P times 1 minus P is greater than or equal to 10, and N is less than 0.05 big N. (10.3) is a one means test, one mu test, or one sample means test. So H naught and HA will both have mu in it. Mu equals or mu doesn't equal. Criteria here. We want N to be greater than or equal to 30. That's usually just seals the deal for everything. But we do need independent, simple random samples. And we really don't want any outliers. The outliers are never really representative of the whole, and so they're like bad. They skew all the averages and stuff, and so that they're not, they actually hurt the value. Sometimes it will say you're normally distributed and you're good to go. And that should be sufficient. Assuming like independent random samples and shit like that. Like that shit never changes. Well, that's not true. There's one test that the shit does change. It's called the paired test, and you need dependent samples there. We'll cover that later today. All right, so the questions we're going to cover. 10.2, I'm going to do, what am I looking at, number 4. And this is on darts at stock pages. And there's not a lot of math here, but there is like an understanding of what the hell. This question is about what is p-value? That's the question we're trying to answer here. And if you convert it to a percent, it's the percent of samples that should have a value as extreme or higher. I'm going to say more extreme because sometimes we're going low than the current sample. If H0 is true. So it's always related to the information about H0. You'll see how this works out on the direct question in a second. All right, so let's take a look at the problem. So you'll see this when you're doing your homework. Some have argued that throwing darts at the stock pages to decide which companies to invest in could be a successful stock picking strategy. Suppose a researcher decides to test this theory and randomly chooses 200 companies to invest in. So he throws darts and finds 200. After 1 year, 106 of them are considered winners. That is, they outperformed other companies in the same investment class. To assess whether the dart picking strategy resulted in a majority of winners, the researcher tested H0 as P equals 0.5 versus H1 where P is greater than 0.5 and obtained a p-value of 9.1981. Explain what this p-value means and write a conclusion for the researcher, assuming alpha is greater or alpha is 0.1 or less. The p-value is 0.19181. So as a percentage, we had p-value is 0.1981. That's 19.81% or about 20. Which means 20 out of 100 samples, that's 20%, should have a result which is just as extreme or more. If H naught is true, i.e. if P equals 0.5. They also gave us an alpha. Oh, let me let you finish writing that. So they gave us alpha is 0.1 or less. If I compare the p-value, which is 0.1911981, against 0.1, which is alpha, the p-value is greater than it. Greater than, it means it's not too low. Do not reject H naught. Do not support HA. And not enough evidence. All our nots go together. You will see that you get tired of writing do not reject and do not support. I recommend shorthanding this to DNR H naught and DNS HA. I know DNR means do not resuscitate, but I'm sure they're going to ask us about this as well. Okay, let's go take a look at it. It says choose the correct explanation. We were talking about 20%, so 20 out of 100 samples. Two of them say that. A and C both say 20 out of 100 samples. Then we want to look at the ones that give us extreme or more, which in this case, since it's greater than, would be higher or as high or higher than the P equals 0.5. So A says if the population portion really is greater than 0.5, that's not H naught. H naught, that's HA. We don't want HA, we want H naught. C says about 20 in 100 samples will give a sample proportion as high or higher than the one obtained in if the population proportion really is 0.5. That matches up with our H naught, and that matches up with our 20% from our p-value. So that's the one we want. Now it says choose the correct conclusion. And it looks like they're comparing p-values because the p-value is large or p-value is small. We saw that the p-value is large, it's too large. So the p-value was too large, it was not too small, so we do not reject. The p-value is large and do not reject looks like B. Which means there's not enough evidence to conclude that the dart picking strategy works. Or is better than just guessing. That's really what it's asking. Is it better than guessing? Okay. Any questions on that? All right. I'm going to go to number 6. Number 5 and number 6 are about the same. They ask the same shit. And I didn't want to go through 5 and finish it. All right, so number 6, let me bring the camera back, document camera back up, and write down what it's talking about. 10.2, number 6, is about math and science in school. Teaching in school, in high school. Is it a problem? Are they not teaching enough? So that's what the problem's asking. And it says 20 years ago, 53% of parents thought it was a problem. A recent survey, so current information, shows that 305 out of 850 think it's a problem. And the question they're asking is, do parents feel differently today than 20 years ago? And they give us alpha equals 0.05. Now on this problem, they want us to test the criteria first. So it shows it on the screen. We're going to walk through the criteria. Recall the criteria was n times p times 1 minus p is greater than or equal to 10, and n is less than 5% of the population. They asked 850 people, that's our n. And the p that we're checking it against is that one. So we're going to plug those in. 850 times 53% would be 0.53 times 1 minus 0.53. Is that greater than or equal to 10? This is some calculator mojo. And I'm getting 211.735 is greater than or equal to 10. Now, I don't know the population for parents of high school students, but I'm pretty sure 850 is less than 5% of them. Like, there's a lot of fucking parents in the country. There's probably more than, that's probably like 5% for like half of California, let alone the entire country. So it doesn't say it, but we can assume this is true. It's a reasonable assumption. And we can assume that it's random. Those feel like safe assumptions. So we meet the criteria and we can do the test. So let's do the test before we go do the homework problem. Our 5-step test. This is a one proportion test. and the proportion that is the old value, H naught is usually the old stuff and HA is usually the new stuff. The old information was P equaled 0.53. It says parents feel differently. Differently isn't greater than, it isn't less than, it's not equals. So we will have not equals as our HA symbol. That's step one. Step two, make sure you state what alpha is. Alpha was given to us, so we don't have to come up with one. Step three will be our test statistic and our p-value, which we're going to have to go to StatCrunch to get. Ready to go look? Let's do that, finish the test first before we do the homework problem. So we're going to go over to StatCrunch, and what we do for proportion tests, chapter 10 and 11 are both going to use stats, proportion stats. Chapter 10 is one sample, chapter 11 is two sample. So we're doing one sample, we don't have data, we have summary. So stats, proportion stats, one sample with summary. They said 305 people out of 850. 305 people are considered a success here. They think it's a problem. 850 was our N. Hypothesis P equals 0. The P is if you pick the right test, it says H naught correctly already. P equals. But we just got to put in the value here. And notice when I enter the value here, it changes it on HA. So you can't fuck that up in StatCrunch. If you do put in the right value for the thing, you're going to be good there. The only other thing you got to check is this symbol right here. Always check to make sure you're using the right one. If you do less than or greater than when it's not equal to or any of the other combination, you're going to get the wrong information. We were doing not equals to, so we're going to leave it like that. And I get this Z stat and this P value, which it might be too small to read, so I'll come over here and write down over here. Negative 9.9992325, and the P value was less than 0.0001. Let's finish our test and then we'll do the homework problem. Step 4 is compare these. My p-value is, it says less than 0.001, we'll use that. And we're comparing that to alpha, which is 0.05. P-value is lower than it. So too low. Reject the hoe. Support HA. If we support HA, that means there's enough evidence to support it. There is sufficient evidence to support the claim that parents today feel differently than those 20 years ago about the problem with teaching, problem of math and science in school. At alpha equals 0.05 level of significance. If this was my question on the test, this is what I'm expecting to see you put. You will be given the information from 3. All you're doing is picking, okay, first you're going to tell me what kind of test it is. It's a one proportion test. You'll tell me what H naught and HA are, which is always based on this up here. If 2 isn't given to you, use 0.05, but most of them will have it given to you. 3, I'm going to give you all the information. Then the real thing that you really got to do is 1, 4, and 5. That's where the work is on your part. Make a decision. I strongly recommend when you're doing it on the final, write this shit down. You make a decision here, do that, then write the statement. I get students that put a symbol here, it's not always right, they don't tell me what it means, and then they get shit like, there's no connection between what they have in 4 and 5. I didn't write 5 here, this is 5. Our conclusion.
And that's 80% of the final.
There's 8 problems just like this.
Nice.
Right?
Yeah.
You're going to have a 1 proportion test. You're going to have a 1 means test. You will have a 2 proportion test. You will have a 2 means test. You will have a 2 means paired test where the groups are related. And then we have 3 or more samples, which is tomorrow. I'm not doing it in here with you guys tomorrow. So check this out. This is how I'm going to get you guys extra work, being able to see extra problems done by me. In the morning class before you guys from 7 to 9, I'm going to do chapter 12 and 13. For you guys, and I'm going to record it and post it. For you guys, we're going over the practice exam tomorrow. That's going to be recorded and posted. So between the two, you'll be able to see a little problem work out from each section for every homework section. In addition to what's in the lecture videos and stuff like that. But yeah. So we got the 3 tests from chapters 12 and 13, and we are covering 5 of the categories today, which is 50% of the test. If we get to see all 5 categories, that's a different question, but we will talk about the criteria and what makes them unique. Any questions? Let's come over here and finish this bad boy out. So what did it says because n times p times 1 minus p, that was, I calculated it at 211.735. It says 1 decimal place, so 211.7. That is greater than 10. And the sample size is less than 5% of the population. And the sample can be reasonably assumed to be random. It's either given or not given or assume, and then whether or not we can assume random or not. There's no reason to think they picked 850 high school parents that were together. The requirements for testing this hypothesis were satisfied. Now they're going to walk us through some of the shit on the test. We had P was equal to 0.53. and P was not equal to 0.53. The test statistic to 2 decimal places is -10. If I round to 2 decimal places, it's -10.00. And the p-value to 3 decimal places is actually just 0. It was 0.0001. So we had p-value was less than alpha. We're rejecting H naught. That's what we're looking for. P-value was less than alpha. These bottom two both say less than alpha. C says reject H naught. They're kind of like merging 4 and 5 together. They say reject the null hypothesis, but the conclusion is always about HA. There's sufficient evidence that parents feel differently today. I was a little more verbose in what I wrote here, but they said the same thing. Any questions? Okay. So next one we're doing is number 10 in here. And I think number 10 is really worth going over, like what's happening here, because like it'll show you the connection. What did I finish? I didn't click check answer. Ha! Similar question. Okay, number 10 is a blind taste. I'll put this, write all this information down in a second, but just reading it to you, a blind taste test is conducted to determine which of 2 colas, brand A or B, individuals prefer. Individuals are randomly asked to drink one of the 2 types of cola first, followed by the other cola, and then asked to disclose the drink they prefer. Results of the taste test indicate that 54 out of 100 individuals prefer brand A. Complete parts A through C. A is conduct a hypothesis test for P equals P naught, and H1 is P does not equal P naught. And then they ask us to do a range of values from 0.43 to 0.65 at alpha equals 0.05 level of significance. We're going to see that there's a range that we do not reject H naught for, and everything outside that range we're going to reject. So, like strategically, how do we go about doing this? Number 10 is the soda problem. And my example has 0.43, 0.44, up to 0.65. And they want us to know which p values do we not, or which p's do we not reject H naught for. So, when we do not reject H naught, that is when p-value is not too low. So p-value is greater than or equal to alpha. That's what we're looking for. We're looking for p-values that are greater than or alpha. And so like, I'm going to do a little number line here. Like, the middle of the range is 0.55. That's roughly the middle. Then I'm going to do like little blocks of 5. alpha here was 0.05. We're going to find a range of values here that work. This is directly related to confidence intervals. The confidence intervals when HA is not equals is 1 minus alpha times 100%. Did I say that to you guys earlier? Yeah, I did. So like if alpha equals 0.05, 1 minus this is 95. So this corresponds to a 95% confidence interval. What this problem is trying to do, and they're going to ask you this later on, is how does this compare to a confidence interval? They're trying to show you the slow fucking way, how to see that there is a range of numbers like the confidence interval that works. We're going to work smarter and not harder. We're going to let's find the confidence interval for 95%. And test values that correspond to that. So we're going to find the 95% interval. I'm going to come back over here and plot it on this graph that I got. And we're going to reason out what we're going to check. I think this is some huge intuition shit for like how all this shit works. Like this is a bunch of mojo magic fucking bullshit. It's not. It works. Everyone ready? Nope, Jared's still ready. I can wait. Oh, you're good? Just okay. So I'm gonna need this 54 out of 100 information. Where is it? Get more help, StatCrunch. We're going stats, proportion stats. Again, one sample with summary. We had 54 out of 100. And I'm going to do a 95% confidence interval. And I'm going to come over and I'll write down where it's easier to read what those values are. So my lower limit is 0.4423159, and my upper limit is 0.6376841. So like 0.442 and 0.638. Where does that show up on my map? Up here, on my confidence interval things, 0.442 is right about there. And 0.638 is like right about there. So this is my 95% confidence interval. We do not reject values in this range. And it always corresponds to the alpha. Alpha was 5, so it gives us 95%. Yeah.
Yeah.
Sorry. Okay, are you guys with me so far? So they wanted us to check a bunch of values, and they were increments of 2 decimal places. Now, if we look right around 0.442, I've got 0.44 and 0.45. 0.45 is in the region. It should have a p-value greater than alpha. We're going to check it. 0.44 is outside the region. The p-value should be less than alpha. When it's outside, we reject. We reject outside. We do not reject inside. And we'll do the same thing when we come over here. 0.63 is on the inside. So that should be in the p-value is greater than alpha. And 0.64 is on the outside. So here p-value should be less than alpha. I'm going to check those values. Rather than checking all fucking 20 values that they give, let's work smarter, not harder. This is where you see the tie-in directly between chapter 9 and confidence intervals and chapter 10 onward with the hypothesis testing. And after this, we'll take a little break. Ready? All right. So they wanted us to test this. I'll leave that open. I think that's handy to keep open so we can see it. And we can look at it and compare it. We're doing proportion stats, one sample with summary. We still have the 54 and the 100. I think that's what it was. And I said that 0.44 is going to be lower. Let's check that. If I do 0.44, what is my p-value? My p-value is 0.044. See how that's lower than the 0.05? And now if I change, I'll do a new one so we can compare them right next to each other. Proportion stats, one sample with summary. Again, 54 and 100. And the one that was just inside of it was 0.45. We'll do 45. And now notice as we go from 0.44 to 0.45, our p-value goes from below 0.05 to above 0.05. So 0.45 is in the do not reject zone. It's a safe value. I'm going to check the other one. 63 was in, 63 should be a safe value. It should be above 0.05. If you don't want to do this, like make a whole bunch of windows and type it every time, you can always do options and edit and just change the value you're looking at. .63 was above 0.05. And the other one I was going to check was 0.64. I'll edit this one. And that one is below 0.05. So we can see that those are the threshold boundaries. They want the ones that were above. So that was 0.45 and 0.63. .45 and 0.63. Construct a 95% confidence interval. We already did this. What 3 decimal places is what they want. The lower limit 1 to 3 decimal places was 0.442. And the upper 1 to 3 decimal places was 0.638. And now it says, suppose you change the level of significance in conducting the hypothesis test to alpha equals 0.01. What would happen? Let's come back and look at our picture and talk about that. So alpha was 0.05, and that was 95% confidence. If we switch to alpha equals 0.01, we gotta do 1 minus that. And we're gonna get 99% confidence. If 95% is this wide on the confidence interval, 99% is a little bit wider. I think we talked about that yesterday, or it's at least in the lecture videos. So if it's wider, like let's come up here and look at our number line up here. What does a wider confidence interval mean? Like it's going to be something like that. It's going to include more values. It will include more values for do not reject. Does that make sense? We've widened our region. It's because the confidence interval goes up accordingly. When alpha goes down, confidence goes up. So the range of values would increase. That's A and D. A says the confidence interval increases. D says it decreases. A is the correct one. The range of values would increase because the corresponding confidence interval would increase in size. All right, let's take a little 5-minute break. I'll stop recording. So we're gonna jump to 10.3. I'm gonna do problem number 4. I'll show it to you in a second. It's on computer stocks, daily volume. And it says in 2011, the mean daily volume was 35.1 million shares. In 2014, they think it's different. So they collect data from 30 trading days. And since we're doing daily volume, that sure as hell sounds like our N. N is 30. And in that period, the analyst finds that the sample mean, remember sample mean is X bar, sample mean is 25.8 million. I'm just gonna put a big M. I know that's not the right symbol, but I'm tired of writing it already. And it has a sample standard deviation of S is 14 million. And the question says, test the hypothesis by conducting a 95% confidence interval. lot of these problems in this fucking new edition are doing this shit, and it pisses me off. They're overemphasizing like the relationship between confidence intervals and fucking hypothesis tests. Let's just let them do it one way. It's fucking easy. Well, we're gonna do our regular 5-step test, and then we'll tie in the confidence interval afterwards. What you're gonna be tested on will be something like this. We'll do the 5 steps. Step 1, remember, is H naught and HA. H naught is a statement of equality. It's always the old stuff. So mu equals 35.1 million, which means HA has the same mu, the same 35.1 million, but they think it's different, which is not equal. They gave us a confidence interval. They didn't give us alpha though, but like we can work with that. Like 1 minus the alpha thing, that turns into the CI percent. We do a little bit of algebra. We can do 1 minus the CI as a decimal equals alpha. So 1 minus 0.95 is 0.05, and that will be our alpha. That's step 2. Alpha equals 0.05. Step 3, we need a stat and we need a p-value. That's going to be some StatCrunch work. While we're there, I'm going to write down the upper limit or lower limit and upper limit as well. Because that's what they want for the homework problem. You guys ready? You good, Jared? All right, get more help. We're going to use StatCrunch. Oh, I will write this down in a second. It's the exact same thing as the proportion, but we're doing t-stats. So we did proportion stats, 1 sample with summary. Here we're doing t-stats, 1 sample with summary. In fact, let's look at these real quick. Look at the difference between these two. 1 sample's got with data, with summary, power sample. T-stats, 2 sample has with data, with summary, or power sample. Paired doesn't have anything. It requires you to have the data. You don't get a choice. We go to proportion stats. It's got the same shit. 1 sample with data, with summary, power sample. 2 sample with data, with summary, with power sample. This is like all of chapter 11 and all of chapter 12 right here, these 2 menus. We're doing t-stats, 1 sample with summary. For these, you need the sample mean, standard deviation, and n. We have all those. The sample mean was 25.8 million. I tested this earlier. It doesn't matter if we convert it to million or like do 25,800,000. We can do it like this, leave it as a decimal, and you get the same answer, which is good to know. Standard deviation was 14 million, and the sample size was 30 days. And the hypothesis test we were doing is mu equals 35.1 million. And mu did not equal 35.1 million. So I'm going to write down the t-stat. It may not be easy for you to read. I'm going to write down, I'll bring up the camera in a second, because I want to get the lower and upper limits real quick too. If you're reading it and writing it down, I'll wait for you. Both good? Okay. Rather than redoing and typing that all in, I'm just going to go in and I'm going to change it to confidence interval. Bam. And my lower limit, I don't know how many fucking things decimal places are going to want, and they always want more than I fucking write down, so I'm just going to write them all down. 20.572314. The upper limit is 31.027686. All right. Now you won't need to write down the lower limit and upper limit because I'm not going to give them to you. You're not having StatCrunch with you. But you should do the stats and the p-value. Step 4 is we compare the stats and the p-value, or the p-value and alpha. P-value was 0.0011 and alpha was 0.05. The p-val is too low. Reject the hoe. Support HA. So if I write a statement of conclusion here, this is what you would do on the test. Support HA means there is sufficient evidence. There is sufficient evidence to support the claim that and the problem is about the mean daily trading volume of computer stocks in 2014. That the mean daily trading volume of computer stocks in 2014 is different than 35.1 million at alpha equals 0.05 level of significance. I gotta tell you, you cannot assume that this is gonna be the same answer when you do it. When I did it this morning, we did not reject it. So the problem has different answers. This one isn't always gonna be reject H0. Let's look at how they want us to do it. Using the number line, the lower limit is 20.572. And the upper limit is 31.028. And 35.1 is way the fuck over here. It's outside the range. This is our confidence interval. If it's in the confidence interval, it's safe. If it's outside the range, it means it's unusual, which means it's probably wrong. That's why we say we reject it. If 35.1 is correct, it's really unusual that we got the sample that we did. Does that make sense? Let's come put that shit in StatCrunch or in the homework. We have mu, we're talking about mu's. And the second one was not equal because it says different. To 3 decimal places. This is why you write them all down, because it's irritating as hell when you don't have enough. And so we are rejecting the null hypothesis because the 35.1 million is outside of it. So B and D both say reject. B says it falls in the confidence interval, and that's not true, it's on the outside. D is rejected because it does not fall in the confidence interval. Any questions? All right, we are going to take a look at chapter 11. Chapter 11 is on our two-sample test. Oh, I'm sorry, I didn't write that. I told you I would write it down. Stats, T-stats, one sample with summary. If they give you a data table, you got to do the data table one with data. But a lot of times they don't do the data table. All right, you guys ready to talk what's next? Chapter 11. Chapter 11 is on our two-sample tests. .1 is on, I call it my 2P test. It's the proportion test for two samples. .2, for some reason they went to the paired means test first. So this is a means test, but they're dependent samples. We'll talk about that criteria in a second. And then 11.3 is a two means test where it's independent means. For two samples. All of these are two samples. So last time we talked about the criterias. So what are the criterias for these? 11.1, that's our proportion one. It's going to look very similar to what we did with one sample. In one sample, we had n times p times 1 minus p is greater than or equal to 10. Well, now we got to do it twice. We got to do it for the proportions in group 1 and the proportions in group 2. You also still need n for each group to be less than or equal to 5% of the population. .2 is the paired test. This requires data. And the two samples need the same amount. That is not a guarantee that it's a paired test that they have the same amount. Because we get 11.3 is a two means test, We could have data and we could have two groups that are independent. Needs the same amount, so it's not a guarantee, but there are two samples and we have the data. We need them to be simple random samples. We want n to be greater than or equal to 30, or normally distributed with no outliers. Normally distributed, we would see by the QQ plot, doing the correlation coefficient. This is chapter 4 stuff, and no outliers. And most importantly, they need to be dependent samples. Group 1 has to have a connection to group 2. Whether it's husbands and wives, brothers and sisters, before and after is a common pairing. Like you check something before something and then you check it again after to see how it's changed. And 11.3, I didn't write down the H naughts, so we're going to do that in a second. 11.3 is the two means test. So we need simple random samples that are independent. No connection between the group. You're still in that category of n greater than or equal to 30, blah, blah, blah. This one like comes down here. That's the same thing. Okay, so how does this testing work? How does this change our H naught? This is huge, this is important. All of these have two groups. So like we're gonna have a P1 and a P2 for proportions. The way we do it is H naught in general is P1 equals P2. And then HA is P1 does not. And we could also have the less than or greater than. The computer doesn't record it like this in StatCrunch. In StatCrunch, what they do is they subtract P2 over. They do minus P2 on both sides, and you get H naught is P1 minus P2 equals 0. And P1 minus P2 for HA is, this is where we have the not equals, less than or greater than 0. And they actually have this is the field you can edit. These are the editable fields. Well, probably not this one. I think it forces that one automatically. We're going to leave this at 0 for almost everything. The only time you don't leave that at 0 is like when you're going like, this one is not only higher, but we think it's more than 10% higher. Like, we generally don't normally edit that one. Now notice, if I have like less than or greater than, it very much matters which group is labeled P1 and which group is labeled P2. So you have to label your groups. Label groups is a must on the test for sure. If you don't label the groups, you're losing points. Because I don't know what you're going to mean when you say P1 minus P2 is greater than 0. Homework tends to give this, tends to tell you which group is which. The paired test changes it up a little differently. Paired test says mu d, which means mu of difference. That's what mu d means. It equals 0. That's our h naught. And HA is the same thing, but not equal to, less than, or greater than. But you have to identify how mu d is. Mu d tends to be mu1 minus mu2, so you have to label 1 and 2. I believe this is what they show in 11.3 uses this. Not the mu d, I think. We're going to start off doing one from 11.2 where it's paired because it's definitely different than anything we've done today. And if we've got time, we'll do one from 11.3 with the two meets. Any questions so far? Everything else is the same. All the 5 steps are the same. These are the only differences in step 1, how it changes. That's nice. It's nice to have a whole test that's damn near consistent. 80% is these hypothesis tests. The other 2 are doing confidence intervals. I will give you the lower bound and the upper bound. Your job is to give a statement of confidence. You'll see it's fucking easy. If you pay attention and just listen to what I say when I'm doing like a practice thing, there's no reason to not get those confidence intervals 100%. And yet, I get disappointed so often. All right, so 11.2, I'm going to load it up in a second. It's number 4. It's about sons being taller than fathers. Let's see what the data gives me here. So first off, it asks what conditions must be met. Required conditions. Samples are dependent. We put this on the other page, but since it's part of the question here, I'm going to put it down here. Samples are dependent. Samples are no more than 5% of the population. And the differences are normally distributed. That's one. And part of that is or a large enough sample. Or large samples. All right. So which conditions must be met? It says they select 13 fathers, I'll write that down in a second, who have adult male children, so that children are adults also. You don't really want to compare a 12-year-old to their dad. That's just fucking ridiculous. They only have 13 fathers. They have alpha equals 0.10. They tell us a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers. They tell us the main conditions are met. They're just throwing in a couple more. They must be dependent. Like, I can't have Cody with my dad. There's no connection there between father and son. It needs to be Cody and Cody's dad. The differences are normally distributed or the sample size is large, and the sample size is no more than 5% of the population. Now it wants D. D is for difference, and I is based, since it's pairing the data, it's matching up father and son. The I represents, like, is it the first group of sons and son and fathers, second son and father, stuff like that. Well, let's see what's going on here. The data table is father is X and son is Y. Father is X, son is Y, and they're doing X minus Y. I'm going to write that down. So they say D equals X minus Y. And in the data, that is father minus son. That's going to be our null hypothesis. Father minus son. So our mu D equals 0 is set up like father minus son. The question is, what symbol should I use for HA? Now, I think this is an easier way to look at it. From here, if we add sons to both sides, I've got father equals son. That's like the default. If we're looking at the mean height, what symbol should I use for sons are taller than their fathers? The father's on the left, the son's on the right, sons are taller. That should be like that. Fathers are less than sons. And so if I subtract that back over, I have father minus sons is less than 0. That's going to be my HA. HA is going to be mu D is less than 0. So I have it written kind of sloppily here, but I have my H naught and I have my HA. That's step 1. Step 2, they give us alpha at 0.10. Step 3, I need a test stat and a p-value. And we'll go get those when you guys are done writing. This step here is tricky for students. The fathers less than sons. Because saying fathers less than sons, even in my head, does not translate to sons are taller than fathers. I would want to say sons are taller, sons are greater than fathers. Well, this does say sons are greater than fathers, but that's the less than symbol. It's fucking confusing the way they did it. I don't know why they put fathers first, but they did. So we got to go with what they did. You guys ready? We'll put that in right here. Mu D equals 0, and mu D was less than 0. That's what we just talked about. And now to find the test statistic and p-value, we got to come over here and look at this. We're going to do stats, t-stats, paired. Now, it's mu1 minus mu2. We need that to match up with what we had. We said that was fathers minus sons. So group one has to be fathers, height of fathers, and group two has to be sons. That way we match up correctly. And here we have a less than sign. If I do that, we get this test statistic. It might be easier if I write it down on a bigger value. I've got negative 0.00983. That should be enough. P-value is 0.4962. We're going to finish what's expected of you on the final first. It's not part of the question, but you'll see how it matches up with what they put. Step 4 is we're going to compare it. I got my p-val is 0.4962. My alpha is 0.10. Is p-value less than or greater than alpha? Feel free to chime in, anyone.
Greater than.
Thank you. Don't make me do all the talking, goddammit. You guys are so quiet. All right, it's greater than, so it's not too low. So not goes with all the nots. Do not reject H naught, do not support HA, and there is not enough evidence. Or there is not enough, not sufficient, insufficient. There's not enough evidence to support the claim. The claim is always about HA, and HA was sons are taller than their fathers. There's not enough evidence to support the claim that sons are taller than their fathers. At the alpha equals 0.1 level of significance. And when you're ready, we'll put this in over on StatCrunch on the homework. And find a problem from 11.3. Everyone was done, right? Okay. My t-stat to 2 decimal places was negative 0.01. They want the p-value to 3 decimal places, which is 0.496. Should the null hypothesis be rejected? The p-value was greater than it. We said do not reject. Do not reject H naught because the p-value is greater than the level of significance, which means there is not enough evidence to conclude that sons are taller than their fathers at the 0.10 level of significance. Notice, like this bit right here, that's my step 4. Do not reject H naught because p-value is greater than alpha, level of significance. Step 5, step 5 is their next sentence. There is not enough evidence to conclude that sons are taller than their fathers at the 0.10 level of significance. Some of these problems like literally have all the steps listed. They just break them up into subparts. All good? Do we have enough time to do a fucking another one? Yeah, write down for like 11.3. What's it give me? Rude. Let's go to number 5. So number 5 is a researcher wants to determine if carpeted rooms contain more bacteria than uncarpeted rooms. This table shows the results for the number of bacteria per cubic foot for both types of rooms. So I'll write down, I'm not going to write down the full data set, but I'm going to write down the problem number so we have it in our scan notes. 11.3 number 5 is uncarpeted rooms. They have the data, and the samples are the same size. Even though the samples are the same size, it doesn't mean that they're paired. There's no reason to think like you're pairing a room with its carpeted versus a room that's uncarpeted. In fact, what would they have in common? You'd have to have a building, this many buildings where one room is carpeted and one room isn't. So it says determine whether the carpeted rooms have more bacteria than uncarpeted. I'm going to write that down. Carpeted, more, let's switch over to camera. Carpeted is more than uncarpeted. And it's talking about bacteria. And they say, let this be population 1, and uncarpeted is population 2. This is mu1 and mu2, and more than means greater than. So if I write that by subtracting mu2 to the left side, I have mu1 minus mu2 is greater than 0. That's going to be my HA. And mu1 minus mu2 equals 0 is my H naught. And we just have to make sure that we use population 1 is carpeted and population 2 is uncarpeted. They tell us that's what we need for step 1. Step 2, they give us alpha. Alpha is given at 0.01. And they even say that the normal probability plots indicate that the data is approximately normal and box plots have no outliers. So they tell us that everything's good, you don't need to check shit. Now we got to finish our test. Step 3, we need the test stat. And our p-value. And we're going to compare that to 0.10 equaling alpha. You guys ready? Wait, no, you're not. I'm being impatient. I'm seeing that clock tick down. I'm going, I want to get this done. So we wanted mu1 minus mu2 was greater than 0. That was this one right here. Or mu1, no, they don't have it as the, this is how normal people say it. That's not how StatCrunch uses it. It's fucking stupid. Now we need to go get the p-value. We need the data set. So I'm going to open this in StatCrunch. We got to remember carpeted is group 1. So stats, t-stats, to sample. This time we have data. We're not using summary, we have data. So if you got the data set, you got to do with data. It makes it a little bit easier. You don't need to enter in the sample means. Group 1 was carpeted and group 2 was uncarpeted. And we wanted greater than. All right, when I do that, the stats get thrown back as 1.9678. And the p-value is 0.0348. So we compare with our level significance. Are we greater than or less than? How do these two compare?
Greater than.
It's greater than, right? If you're unsure, if you're pausing, you're like, I'm all hesitant shit, compare the first decimal. If they're the same, move on to the next decimal. As soon as you get a decimal place that's different, 3 is different than 1, 3 is greater than 1, which means the p-value is greater than the alpha. So p-value is not too low. So we've got our do not reject H0, do not support HA. And there is not enough evidence to support the claim that HA was carpeted, had more than uncarpeted. Carpeted rooms have more bacteria than uncarpeted rooms. At the alpha equals 0.01 level of significance. Zero 0.01 is kind of a low alpha, isn't it? If we had used 0.05, what would have happened? This would be different, right? It would be less than. And we'd have to reject H0, we'd have to support HA, and we would have to say carpeted rooms have more bacteria. This is 5% versus 1%. Like, I think they're being a little picky with the 1%. I would argue with the p-value being 348, this is 3.5%. That's pretty fucking unusual. I would say carpeted rooms have more bacteria based on this, but they wanted at alpha equals 0.01, that's what they get. P-value was 0.035 to 3 decimal places. And we decided we are not rejecting H0. That is either A or D. And there was not enough evidence. A says not enough evidence. D says there was enough evidence. So it's got to be A. Not enough evidence at alpha equals 0.01 level of significance to conclude that carpeted rooms have more bacteria than, yeah, that's what we were saying. All right, 11.1 is on proportions. It's not really any different than this 11.3. The only difference is we're doing proportions rather than means. It is worth noticing, nope, stay here. Go back to StatCrunch. Take a look at when you do proportions to samples, what you need successes and observations for both groups, and they'll give it to you. Okay, they'll say like 45 out of 90 for group 1 and 55 out of 80 for group 2. They'll tell you, they'll give you those numbers. And if you look at T-stats to sample with summary, you need the sample mean, standard deviation, sample size for each group. So it's just like the same shit we did with one sample, but now you need the information about both samples. Okay, that's the only difference. Notice mu1 minus mu2, p1 minus p2, it's all the same shit at this point. The only difference is like what h0 is, what we're putting up top. If you guys don't have any questions, have a good day. Get the fuck out. I will see you guys tomorrow. There's a lot going on here, right? We're almost done.